Welcome to Carlton's Math Corner. Today we're going to be discussing greatest common factor. Let's start off with something to put a smile on your face. I love this with the dog fighting with this lobster. It's not really a scene that you would see in a normal household, so I thought it was pretty funny. And at this time, just make sure you have your math journal out as well as your vocabulary packet. Now in our last video, we discussed factors and we talked about prime factorization. Today we're going to use our knowledge of what we learned on factors to find a greatest common factor. So first let's review what we know about factors. Hopefully you recall this image. This actually shows all the factors of 36. So remember, factors are anything that we can create a rectangle or a rectangular ray from and get the same area. And we're looking for the area of 36. So like 1 times 36 is 36. 2 times 18 is 36. 3 times 12, 4 times 9, and 6 times 6, all area of 36. All of those numbers that we're multiplying together are factors of 36. And so we are going to use our knowledge of factors, and what we're going to do is find the greatest common factor when looking at 2 or more numbers. Okay, so we're going to start off with 2 numbers, and this is called a Venn diagram. And notice at the top on one side of the Venn diagram, it shows the factors of 12. It says the factors of 12. On the other side, it says the factors of 36. Now, a Venn diagram is special because it overlaps in the center. And the center is basically for anything that is in common between the factors of 12 and the factors of 36. So we're looking for numbers or factors that we would put on the 12 side as well as the 36 side. Okay, so let's start thinking, what kind of rectangles can I create to get to 12? Or let me say it as, what kind of numbers can we multiply together? Or what factors can we use to get to 12? Well, 3 times 4. 3 times 4, what else? 1 times 12, 2 times 6. Oops. You guys are excellent at this. Anything else to get to 12? How about on the other side? What factors are for 36? 1 times 36. 2 times 18. What else? 4 times 9. Anything else? 3 times 12. Excellent. And then 6 times 6. And I'm just going to put 1 6 down because we only need to show one of them to show that 6 is a factor of 36. Any other factors of 36? Okay, so now what we're going to do is we listed all the factors of 12, all the factors of 36, and we are going to find the factors that they share that are in common. So let's put all the numbers that they share in the center. Okay, so they share a 1, they share a 2, they share a 3, they share a 4, they share a 6. My goodness, they share a lot here. And they share a 12. Wow, they share many. Actually, all of the factors of 12 are in common with factors of 36. Okay, so greatest common factor means that we are finding the greatest number, the largest number that they both share. Which one is the largest number that they both share? You are absolutely right. The largest number that they share, it's not the 1, it's not the 2, 3, 4, but it is the 12. They would both share a 12, and that's the greatest common factor. So now let's look at another example, and we're going to use a different method than using like a Venn diagram. We are going to use our rainbow method that we talked about with to find factors of numbers. So if you notice, here are our numbers 18 and 48, and we're trying to find the greatest common factor, and we call that the GCF just for short. Okay, and so 18 and 48, we're trying to list all the factors first of all to get to 18. And so rainbow method, I'm taking 1 times 18, 2 times 9, and 3 times 6. Same thing with 48, 1 times 48, 2 times 24, 3 times 36, 4 times 12, and then 6 times 8. Then notice, why is 6 underlined? You're right. Do you notice that they both share a 1, they both share a 2, they both share a 3, and they both share a 6? But out of those 4 numbers that they share together, 6 is the only one that's underlined. And the reason for that is because the greatest number they share is 6. And so that is our greatest common factor. That would be the one number that's in the center of the Venn diagram that would be highlighted because that's the largest number that they share. Okay? So let's do another one. Find the greatest common factor of 36 and 44 using that same rainbow method or list method, whatever you want to call it. And then let's compare answers. Okay, so this is what I found. I have 36. These are all the factors of 36. Oops. Sorry, let's go back. These are all the factors of 36. Then we have all the factors of 44. And what is the greatest common factor between them? What I like to do is start at the end and work my way down to see what is the first number that they share. I don't start at the beginning because if I start at the beginning, then I'm focusing on the smallest number they share. I want the biggest number. So really, if you look at all the numbers, the first number that they share is 4. And so that is the largest number that they share. And so the GCF for this one, GCF, oops, and I want to capitalize, GCF is 4. And so that would be my answer. I'm going to show you another method because sometimes our numbers are numbers that have many, many factors. And so it takes a little bit of time to find their greatest common factors. So I want to show you another method. One of the methods is a factor tree method. And we use factor trees in prime factorization. And so it's kind of using our prior knowledge to figure out the greatest common factor. So here are my two numbers, 18 and 24. And what I did is I set up factor trees for both of them. Remember, factor trees, you're just multiplying numbers to get that number. So I start with 18. 2 times 9 is 18. Then I notice that 2 can't really go any further except for 1 times 2. And I don't want to list a 1. So I know that that's a prime number. I'm going to stop and circle it. Then for 9, I did 3 times 3. And I noticed that 3's are prime, so I circled them. And then I did the same thing on the 24 side. So 2 times 12, and then I stopped, circled the 2, then 3 times 4 is 12, and I stop and circle the 3, it's a prime number. And then lastly, 2 times 2 is 4, so those are prime numbers. And so what do you notice? Why do you think that there is a 2 that's x'd out on both of them and a 3 that's x'd out on both of them? You're absolutely right. Do you notice that each of the trees have at least 1, 2. They share 1, 2 together. This one has a 2 and this one has a 2. So what I'm doing is I'm putting an X by them to show that they share them. Then down here, same thing with the 3. This 18 has a factor of 3 and this 24 has a factor of 3. And so I put an X on them to show that they share them. Now notice I am only looking at the circled numbers. I am not looking at the numbers that are not circled because those are not prime numbers. My eyes should be focused on the numbers that are circled, okay? And so looking at all the other numbers that are circled, do you notice any other numbers that they share? And we cannot repeat the numbers that have X's on them, okay? And so I notice that this has a 3 and that's the only number it has left. And over here I have a 2 and a 2. So there is nothing else that they share. So I'm going to actually move on and I am going to record the numbers that they share. Well, they share 1, 2, so I'm going to put a 2 down, and they share 1, 3. And so what I'm going to do is I am going to multiply them together to find my greatest common factor. And so I'm going to do 2 times 3 and the answer is 6. So my greatest common factor between 18 and 24 is 6. So notice all I did is I made some factor trees, okay? And then looking at all the prime numbers or the ones that are circled, I looked to see what is shared. Well, this one had a 2 and they both had a 2 and then they both had a 3. And so I wrote them down. They had 1, 2 and 1, 3. Now if they would have shared more than 1, 2, I would have to write that down. I had to write another 2. If they shared another 2, I'd have to write down 2 2's down here. Same thing with the 3's. If they shared anything else, I'd have to write it down here because in the end, I'm going to have to multiply all of those shared numbers together to get the greatest common factor. And so let's look at another example. Greatest common factor of 36 and 54. I want you to look at this. So here are my 2 trees. And so notice I break them down, and this is probably what yours would look like on a homework assignment. You don't have to draw the actual trees. And so I just did 6 times 6, 36, break it all the way down. Then at the end, I'm going to put circle around this one, circle around that one, circle around this one, circle around that one. These are all prime numbers, and I know I'm going to stop, circle them, and once they're circled, I notice that there's a 2 here and a 2 over here, so I'm going to put an X on it. There's a 3 here and a 3 here, so I'm going to put an X on it. There's another 3 and another 3, so they both share 2 3's, and so I'm going to put an X on those as well. And so what I notice is they share 1, 2, and 2 3's, so I'm going to write them both down. So when I multiply them all together, the greatest common factor they share is 18. Now the wonderful thing about knowing different methods is that you can choose the method that you want to use. Okay, and so your job is to choose either method that you want to use. Okay, you can use a Venn diagram, you could do a list method, or you can do a factor tree. Really a Venn diagram is kind of like a list method, but I am going to actually add it as a different one. And I want you to actually choose one and tell me why. Why do you prefer it? And this is the problem that I would like for you to find the greatest common factor with. Thank you so much for joining me at Carleton's Math Corner, and I look forward to meeting with you again for our next target.